Hello everyone! Today I'm going to show you how to make beautiful and interactive 3D geologic models that you can then go and embed in your website. We're going to be learning how to do this using a free Python module named VTKPlotter. In this tutorial, we're going to be making this nice model, and this is what it looks like in 2D with just an image of it. But this is what it looks like in 3D. It is interactive. You can move around, look at the model. You can go inside. You can see here we have different well logs in there. You can go and take a closer look by going here into objects, removing different objects like the topography so that you can see closer inside and see what is happening and get a better idea about the data. It also has other really cool capabilities using this engine. You can add clipping planes like right here. You can go and then zoom in and look more carefully inside at what is happening. And all this is created for you in an HTML code via the Python module, and you can then embed that easily in a website. For example, I put that model right inside this website that I have built. So let us get going. To go and make this model, you're going to have to go and click on the link below in the description of the YouTube video. So you can go here, take that link to the binder, and click on enter. Quick note on binder. Binder is this amazing surface that you can go and take Jupyter notebooks and put them online and package it together with all the other packages that you need to run that Jupyter notebook. So that if you send it to someone, no one needs to download anything, no one needs to set up any environment. Everything is ready to go and it's promised to work. Even if different packages change and things update, it will always work. So it's very reproducible. And that's what we're going to be using right now. This is the Jupyter notebook, same as old, but all the packages are already installed for you. So let us get going. First thing first is we have to import some packages. All the packages here are pretty standard. Matplotlib for plotting, a Jelani triangulation package from SciPy for creating the surfaces, pandas for data management, and we're going to mainly be focusing on how to use this VTKPlotter package. So I'm going to go click here on run to go and do all the imports. We see here that it changed from a star to 1, meaning that it finished running. One thing to know about this cell is that we are using this command here from VTKPlotter called embed window, and that is deciding what engine we should be using to make the 3D model. And here I'm using what's called K3D, but you can also use ITK widgets, and I didn't write it here, but I think also panel is a possibility. Or you can use just write false, and then that will pop up a window with just a regular VTK engine. Great, so we did all the imports. Now let us import some more, but this time just import the data. So I can go and click on this cell, and then click and shift enter to load the data. While it's loading, let's see what we're loading. We're loading some land surface, so that's just the topography that you saw previously also. Some surfaces of the 175, 225 temperature, Celsius temperature for this geothermal reservoir. Actually, I forgot to say, the image here that we are making is a geothermal reservoir as part of a project called Forge in Utah. So it's all based on, this is a project sponsored by the U.S. Department of Energy. So all the data is free, and you can look below this Jupyter notebook to see where the data came from. So we're also loading some well data and some border data, some microseismic data. Great, so let us get going. Actually, so we see it finished loading. Let us go and take a look at the data. So I'm going to go and copy paste here, this, and I'm going to click on head. Great. See what's inside of this pandas table. And I can see that it is just the XYZ, so just the vertices of the topography. So that's all you need to do. It's not that hard to do. You can get it off the internet from different areas in the United States and probably abroad as well. So off of the USGS website, if you're wondering. So what do? First thing we do is we create a plotter object. A plotter is like a figure in Matplotlib or in MATLAB, and this is a container that holds your different plots. Next, what do? And also, one additional thing to note about it, to add different items, you just go here and you just add items into your figure container. And then you're just going to show it after you added all your items in there. That's great. So, first thing is we're going to add this topography surface. We're going to be using this SciPy command called Delaunay. So it creates a Delaunay triangulation for you. So what does Delaunay triangulation do is you give it some points over here. So we're going to give it points in the x and y, and what it does is it decides, okay, so I have this point here, who are my neighbors? What's the connectivity between me and my other points in order to form these triangles? So to go and create the surface, you just need to give in, we're going to be using a 2D Delaunay triangulation, so you only give in 2 dimensions, and it will find the connectivity that way. Okay, so let us get back to doing that. So we're going to give it the x and y to find the connectivity with these two, and the z will be given as the vertices. Okay, so that's what we're going to be doing, and we get this tri, which is the Delaunay triangulation object, and we're only going to take in the connectivity matrix that says, okay, so what nodes are connected to one another. Okay, you don't have to think about that too much, just giving you some extra information. Okay, returning to the VTKPlotter module, it has different geometric objects, mesh, points, lines, basic geometric items. But if you think about it, what is a geologic model if not a collection of different geometric objects? That's all it is. So we're going to go and make our geologic model using these basic geometric objects. So for the surface, it is just what's called a mesh. Okay, so we can go put in here the vertices and the connectivity matrix that we created using the Delaunay package, the Delaunay command. Okay, so we're putting that in here, creating the mesh. Now we also want to give this land surface some colors, so we're going to be using the point colors method, and we're going to give it the z values that we got from the land surface, and we're going to give it a CMap terrain because that's just perfect for our situation. And vmin just tells you, okay, we want to use just the values from 1,000 up for the color map so that we don't get, the color blue inside of our model, which is part of the terrain color map. So to run this, I'm going to go click here on Shift Enter. Actually, this might take about a minute or so. The thing about VTKPlotter is that once the geologic model or the 3D model is made, it's very interactive, very fast, like you saw before, very responsive. However, it does take some time if you have very heavy things to actually create the model. Now, we see here that it says that it finished running, but the place to look at is over here, where we see that it still has the sand clock running. So when there's sand clock running, we know it's done. So this can sometimes be a little bit deceiving. We know that it's still thinking about this whole thing. So while it's still thinking, let us continue. Here, we're going to add a few more meshes. So there's really nothing exciting going on here. This is all just taking the data that we loaded and then adding it into this plot figure container. Okay, so it's really not much to review. Again, though, we'll notice maybe there's a few new things. Oh, it loaded. Great. So you see now that it loaded, it's very responsive and beautiful, just beautiful. And this is the container. That's it. That was easy, and it's already starting to look good. Already starting to look good. So let us continue to review what is going on here. Some things that are a bit different is that you can see here that I've given different meshes or surfaces a constant color, some opacity. So the way you can just pile up on here different methods to add different criteria to the surfaces that you're making. So you can take a look here and see what's going on. Now there's also this flag item which tells you to add a label on it. That doesn't necessarily work in K3D right now, but it does work in what I'll show later when you make a pop-up style 3D model. Okay, so these are all the same, just mesh objects, so we're going to continue onwards. Actually, one little thing I did here is because I saw that the top of granite was overlapping with the topography, I wanted to move one of them a little bit down because it was creating these weird 3D effects that were being that there were many dots in the same location. Okay, so next thing that we're going to do is point objects. So this is just going to be the microseismic data that we've loaded in. And points, just very simple. You give it a radius, you give it the X, Y, Z, you give it a color, which is these scalars, which is the microseismic magnitude. So that's the W. And then you just add it, like everything else, into your figure container, into your plotter. Okay? Lines. So here it's a little bit fancier. We're adding in the lines and we're actually extruding the lines downwards a bit in order to make this little wall kind of figure. Okay, so this is a little bit fancier. I think this line here is just the basic component, which is just the XYZ matrix for this well path. Okay, but in general, lines, all it needs to take is an XYZ. Okay, that's it. You just load the data and add the line. It's really a great package, VTKPlotter, pretty simple on getting things done. Okay, so some things here are actually secretly points. Okay, so you can see here, this one's a line, but I think here, there's still some issues when using the K3D engine with giving lines different colors, so you have to, for now, use points and then give colors. But if your points are very tightly spaced, it basically looks like a colored line, so no big deal. So we add here the pressure log, temperature log. One other item that you have in VTKPlotter is if you have a lot of objects, you don't feel like adding them one at a time, you can use this lines command, give it the top and the bottom of different lines, and that can kind of shorten things out for you in terms of time. And then you can add here the name. Of course, I forgot to say that. Always add in the name for your object so you can later identify it. Okay. Some exciting things here are also that you can then, you don't have to do this for your model. Let's say you wanted to scale it so you can see the z-scale a little clearly. That's a very common thing to do in a geologic model. So you can do that as well. All these commands, you can find them in the documentation for VTKPlotter, and this is really quite nice and easy to use. So let us run this, and it will continue to add items to the plot. Okay, this might take a few moments like it did before, so we'll need to wait, and maybe you can listen to me chatting while we are. Okay, we have here the data sources. It's off of this great resource, which has a lot of geothermal data. If you're into that kind of thing, just go to this website and you can download a lot of different data sets. Okay, so I'm going to wait here. Okay, so that took about a minute or so to load, but now it is ready to go. And this is the same model that we saw before. And it is looking gorgeous. Very nice, very nice. And now you're obviously thinking to yourself, okay, that's great. How do I share this cool model that I have made with all of my buddies? So what you got to do is you go here into controls. And this K3D engine is great. You just go here and you click on snapshot. Okay. Might take a few moments here to run. Then it should ask you, would you like to save this file? Okay, so you see it's kind of stretching the limits of my browser, but it worked. And what it creates for us is this 14 megabyte HTML file. And all of this model is all inside of that HTML. Okay, that's all it is. And HTML is just something that you can embed in your website or even open just plain like that in a browser. So if I go over here, I can see I have this model that was just created. Okay, and I click on it. Now it might take a few moments to load here, or not. Didn't take any moments to load. And I can see this model that I created. And guys, I'm just inside Firefox, and I've tested this thing and also works in Chrome. Not sure what's going on with Mac people, but I'm sure it works there too. I would be surprised if it doesn't. Great, so this is amazing. We just went from very quickly to make this great geologic model that I can then share with friends. Like I said again, you should let them know. You could, handle these different objects that we made, turn them on and off. And of course, one of my favorite things I've already shown before is to use this clipping planes and to use it in this from camera mode, where you can just zoom in and it will just show you the different elements, the microseismic, the wells that we have inside. Yeah, so that's basically it. Actually, I'll show you one last thing. If you go into the VTKPlotter GitHub, after you download it, you can go into the example, the advanced folder, and you can find a version of this tutorial for using inside your, not on a Jupyter notebook, but on your computer. So for example here, I think it should be here. Oh, there it is. You can download it, and then you can run it after you downloaded installed your VTKPlotter by just doing pip install VTKPlotter. in your Python environment. So if I go here and I then run this, it will actually look a little bit different because this example, when you run it just with the VTK engine, has a little more capabilities. You can see the model will be a little bit better looking. Also, one note, a thing that I've added to here that's not on the website is this embed window false. And also I've added the embed window into the import. So you can see it's loading data, analyzing. This might take a moment, so I'll wait. Okay, it didn't take a moment. Oh, so fast. Yeah, and this one is actually a much nicer example. Pretty good looking. Yeah, well, this is beautiful, really. We can see that this one actually has the ISO lines in it. It has some pretty fancy extrusion colors. I'm not sure yet. Maybe like a follow-up on that and how to get this kind of beautiful quality model into a website. I only know how to do it with the K3D engine. But yeah, this is great. This is just gorgeous. You can go and share it with all of your friends. Now there is one last thing that I want to show you so that you can go and create your own 3D geologic models. So how are you going to go and do that? Let's say you have your own data over here, this topography.csv, and you want to show that topography. How are you going to do it? So you have two options here. One is if you can get into very complex models, the best option is probably to go and install VTKPlotter. So the way you're going to do that is you're going to go into here, your Anaconda prompt, and assuming you're using Anaconda, and then you're just going to go here and do pip install VTKPlotter, okay? And I think for me, it should probably say something like, you already have it, what are you talking about? But for you, it will probably download and install it, and then using your whatever software you're using for using Python, you can then go like this, and you would just insert here instead of URL, you just put your own data in here. Now, another option, which might be easier if you're not as familiar with Python environments and installing packages, is that you could actually do that within this Binder notebook. And the way you do that is you go over here and you right-click on where it says Jupyter, okay? And then you're going to say Open a New Link, okay? And what this brings you to is the secret folder system that's available online. And you can see here are hidden all of these CSVs, actually, that I also have here as well as in the GitHub. And what you could do is you can say, okay, let me go here and upload my own CSV. So I think that was inside, where was it? Okay, let's just go like this. Yeah, like that. And I'm going to go and upload my topography.csv. I'm going to click here on upload. Great, it's going to take a few seconds, and now it's right here in my file system. So all I need to do is, I don't need to download anything, I go back to here and I say, okay. So first of all, I'm going to click here and shift enter to import the data. And then I'm going to go here and click on add cell. I'm going to say, okay, well, let me just, I need to read in the CSV. So I'm going to go here and I'm going to copy this section here. And then instead of this URL plus, I'm going to go and give it the name of my CSV. So that's topography. Great. And then I'm going to say, okay, what else do I need to do here? So first, let's see that this works. Looks like it works pretty well. So I'm going to say, okay, let's look at it and make sure it loaded. Looks pretty good. Okay, I'm going to make here another cell. And then all I have to do is copy this kind of template that is here and put it over here. Perfect. And I actually don't think I need to change anything else, right? Because I actually called it the same, and it has the same kind of style, this XYZ, and it has the same object name. So let's see what happens if I do shift enter over here. Okay, it says analyzing. It looks like it ran, and let us see. And indeed, you will notice that this is a different topography, right? It's a different one. It's a new topography that it's mine for a different data set that I'm working on. And it is right over here and ready to go. Wow. So it's that easy. You can either, like I said, two options for your own models. You could go and run it in Spider or whatever Python IDK or whatever development environment you're working in, or you could actually just do it here inside the binder. So that's all I have for you today. I hope you learned and enjoyed this tutorial, and have a wonderful day.